Hello everyone, myself Anamika Goyal, Assistant Professor in the Department of Computer Science and Engineering AI/ML from ABES Engineering College, Ghaziabad. In today's lecture, we'll discuss about the topic Connection Oriented Protocol TCP, that is in Transport Layer Protocol. In this lecture, first we'll discuss about the introduction to TCP protocol. After that, we'll look at TCP header. Then next, we'll discuss about the application of TCP protocol. And at last, we'll discuss about the advantages and disadvantages of TCP protocol. Without further delay, let's start our topic, TCP protocol. Now, TCP transmission control protocol, it is a connection oriented protocol. Now, what did it mean of connection oriented? The meaning of connection oriented is before transmitting the data, TCP protocol first establish a connection between sender to receiver. For establishing the connection between sender to receiver, TCP protocol use three-way handshake method. Three-way handshake method. Just because of TCP to establish a connection between sender to receiver, TCP protocol provide reliability. The meaning of reliability is here. TCP protocol provide the guarantee of delivery of packet sender to receiver. Right. Next one is TCP protocol. It is a byte oriented protocol. What is byte oriented? Byte oriented means from application layer continuously send the data to a transport layer without any kind of limitation. But transport layer will break this continuous bit of data at a byte level into a various segment. This process is called segmentations. And what about segment? It is a collections of byte. So basically transport layer break the data at a byte level. So that's why TCP it is a also called byte oriented protocol. Now, TCP protocol work in a full duplex mode. What is full duplex? The meaning of full duplex here, both sender and receiver transmit data at a same time. So this is full duplex mode. Both can transmit at the same time. Next one is TCP protocol maintain order of data because TCP protocols maintaining the sequence or ordering of data because in TCP header we use a field sequence number. With the help of this sequence number at the receiving side, we can reassemble the message in a proper order. TCP provide process to process communication with the help of port number. TCP protocol provide reliability and flow control. Here, what is mean of flow control? The meaning of flow control is to limit the rate at which the sender can transmit the packet into a network. Next one is TCP protocols provide congestion control. Now, what is congestion control? The meaning of congestion control is if I am sending the data more than the speed of the receiver would not be able to receive that data. So, what happened? The number of packet will be stored or congested in intermediate routers, intermediate device. So this will create the congestion in a network. So this is called congestion control. TCP protocol basically use go back and ARQ method or selective repeat method for sending the data between sender to receiver. TCP protocol also use the concept of piggybacking for acknowledgement of the data. What is the concept of piggybacking? The meaning of piggyback when the receiver send the acknowledgement to the previously sent data with the acknowledgement of previously transmitted data, we can also send data receiver to sender. So when we send data with acknowledgement, then this method is called piggybacking. Right? Now we'll discuss about the TCP header format. TCP, if I am talking about the TCP header format, to TCP protocol basically transmit segment from sender to receiver. Here TCP segment is divided into two parts. First one is the TCP header and second one is the TCP payload. Payload is nothing but it is a pure data, so which is received from the higher layer, application layer, right? So when TCP protocol transmit a data between sender to receiver, they always add its header with this data. Its header with this data. It's in the, with it data. Now we'll discuss about a TCP segment structure. In TCP, the header of the TCP header is not a fixed size. It may vary from 20 byte to 60 byte. So the minimum header size of TCP header is 20 byte and that max ranges to 60 byte. And the rest of the information will use to transfer the actual data in the form of segment, right? Now we'll discuss about the TCP header format in detail. So TCP header format, first field is source port and second one is destination port. We know that port number, it is a 16-bit number. So the range of TCP source port and destination port is vary from 0 to 2 raised to the power 16 minus 1. It means 0 to 65535. Out of this range, 0 to 1023 port are known as well-known port, like SMTP use as a port number 25 for transmitting the email from sender to receiver. Some out of this, some port are registered port. These port number are used to identify the source and destination uniquely in the network. Suppose I am sending one message using TCP header from sender to receiver. It may be possible at that moment multiple applications are running on my PC. Each application running in the network has assigned some port number by the operating system for the so this source port address is used to identify the source application process uniquely in the network. Similarly, when the segment sender to the receiver, it may be possible at the receiver side multiple application running on that machine. So, which application process will ready to accept this segment is also identified uniquely with the destination port number. I hope you understand source port and destination port clearly. Next field of TCP header is sequence number. It is a 32-bit field. This sequence number field is used to reassemble or maintain the order of TCP segment from sender to receiver side. Next one is the acknowledgement field. Acknowledgement field, it is again a 32-bit number. It is used to transmit it is used to identify the acknowledged data. Now, when suppose I am sending data from sender to receiver, then receiver will acknowledge those data because TCP provide reliability with the help of this acknowledgement facility. Now, acknowledgement number basically represent the next segment number which expect by the receiver. This is an acknowledgement number. Next field is header length. Header length field represent the total length of the header. The total length, it may be vary from 20 to 60 byte, like 20 to 60 byte. Next 6 bit in this header is reserved for future use. Next one is the control bit. Control bit are also known as flag bit. They are 6 in number. First one is URG bit. Second one is ACK bit. Next one is SYN bit, then FIN bit, then PSH bit, and then RST bit. Like first flag bit is URG. URG stands for urgent bit. This bit is set when TCP segment used to transmit urgent data. Next one is ACK bit. ACK stands for acknowledgement. This bit is set when receiver transmit or acknowledge the previously accepted data. Next bit is PSH bit. PSH stands for push bit. The value of push bit is 1. It means when when sender transmit one byte of information to receiver, receiver quickly receive this information without waiting to fill the buffer, right? So it means push bit is used to transfer quickly data from sender to receiver side. Next one is SYN bit, SYN bit. SYN bit is used for the connection establishment in TCP protocol. When TCP protocol is establish the connection between sender to receiver, the first bit sent by the TCP protocol is SYN bit. So SYN bit is used for establishment of the connection between sender to receiver. Next bit is FIN, that is FIN bit. FIN bit is used, it is the last bit used in connection termination process. When the data transmission between sender to receiver is complete, then finally sender send the signal to receiver, that is with the help of FIN bit. Notified that the connection will terminate between sender to receiver. Last control bit or flag bit is RST. RST bit stands for reset. This bit is set when we want to reset the connection between sender to receiver. So these all are control bit. Next one is window bit. This is a 16-bit field. Basically, this represents the receiver window size, right? When TCP protocol is established the connection between sender to receiver, then at the time of connection establishment, both sender and receiver can send their capacity of the window to send and receive packet, right? This is the window size. Now, next field is checksum field. Checksum, it is a 16-bit field used for error control in TCP protocol. In transport layer, we use checksum field for error detection and control. In network layer, in data link layer, we use CRC, cyclic readiness check method for error control and detections. Next one is urgent field. This field is used to tell the range of the urgent data between sender to receiver. Next one is option field. If I want to transfer some extra information in TCP header, so with the help of this option field, we can transmit extra information in the form of set. So this is all about TCP header. Now we'll discuss about some applications of TCP protocol. TCP protocol is basically used for text communication like WhatsApp, Instagram, because it is a connection-oriented protocol. It supports reliable transmission, so we can use TCP protocol for WhatsApp communications or Instagram or Google, etc. TCP protocol is also used to transfer the file when we cannot tolerate the loss of data and receiving the data is in correct order. These are some applications of TCP protocol. Now we'll discuss the advantages of TCP protocol. The first advantages of TCP is flow control. TCP protocol provide flow control method. Here the meaning of flow control is to limit the rate at which the sender can send the packet to the network. Next one is TCP protocol support error control. Here the meaning of error control is that suppose if I am sending the data and their data may be corrupted due to some noise, so the person who are receiving that data, at least they should know about the data isn't corrupted. So TCP support error control mechanism. And next one is TCP protocol also provide congestion control mechanism. We already discussed about the congestion control. Suppose I am sending the data more than the capacity, the receiver would not be able to receive that data. So remaining packet or data will or segment will stored in the network after some period of time. It may be possible the intermediate router or network will be failed. So at that moment, the packet start will loss. So it may be necessary to synchronize the sender and receiver speed for data transmission. TCP protocol provide process-to-process communication or end-to-end delivery of the message with the help of port number. So these are some advantages of transmission control protocol. Last, the disadvantages of TCP protocol. TCP protocol header size is not fixed. It may be vary from 20 to 60 byte. This is the overhead. Now, TCP as compared to the user datagram protocol, TCP protocol has large header, more number of field involved in TCP header, but it provides more as compared to UDP protocol. It provides more functionality, so these are some, but it little bit increase the complexity of the data transmission. So these are some disadvantages of TCP protocol. These are the references used in my presentation: data communication and networking by Frausen, and computer network by Tannenbaum. This is all about in my side. Thank you for watching my video.